This is Chapter 2, Part 3, and we're going to start by looking at number 30, where we're going to find the slope of each line graphed below. So we're just going to take a look we'll do B and C. So if you take a look at B, if I zoom in, you're going to take a look and you're going to see, okay, what's my rise and my run? So going from this point here to this point here, I'm going to make a slope triangle. So I'm going down 3 units, and I'm going over 2. So my rise over my run, my change in y over change in x, is going to be -3 over 2. Taking a look at part C, we don't have the specific points like we do in A and B. So this time we're going to find those lattice points, and I'm going to pick a point here at -1, -3, and at 4, 1. And I'm going to do my slope triangle. So I'm going to go up 1, 2, 3, 4 units and go over 1, 2, 3, 4, 5. So my change in y is 4, and my change in x is going to be 5. So my slope is going to be 4/5. For 31 on the grid provided, we are going to graph the line y equals 3/5 x minus 1. So we're going to start by identifying the y-intercept, which is a -1. And then our slope, which is 3/5, will go up 3. 1, 2, 3, go over 5. 1, 2, 3, 4, 5, and we'll put a point. And you only need 2 points to draw any line, so we can connect them. I'm going to do another point. I'm going to go down 3, 1, 2, 3, over 5, 2, 3, 4, 5. And I'm going to try to nicely connect them with a line. And make a note that that's my A. For my B, we need a line with a change in x of 4 and a change of y with -6. So we're just given the slope, -6 over 4, which can be reduced to -3/2. We're not really given any other information, so I'm going to make this one, I'm just going to pick some starting point, let's say here. So that's 1, 2, 3, F4, y-intercept of 4. So we're going to go down 3, 1, 2, 3, over 2. Go down 3, over 2. And again, you only need 2 points to draw any line. So I'm going to add a couple more. And then I'm going to connect them together as straight as I can. It's the red. Okay, part C, x minus 7. So our y-intercept is going to be -7. I'm going to have a point down here. My slope is a 1, so I'm going to go up 1, over 1, up 1, over 1. So we're going to have a line with a slope of 1. And then we can connect those together. And then D, we have a line that has a change in y of 3 and change in x of 0. So the slope is undefined because we can't divide by 0. So that means that this is going to be a vertical line. And it could be anywhere. I'm going to put it right here. And again, I apologize for not being super straight. So it can be any vertical line. So in number 32, which of the lines that you graphed in 31 represent a function? If the line does not represent a function, why not? So all of them, so we can say that A, B, and C were functions, and D was not. And it's not because it doesn't pass the vertical line test. And I'm going to abbreviate with VLT, so vertical line test. So 33, equations for linear patterns can be written in the form of y equals mx plus b. X and y represent variables, which are the unknown values. So when you wrote equations relating the figure number to the number of tiles, what did x represent? X represented our figure number. And then the y represented the number of tiles. So m and b are parameters, which are constant values. They do not change within the situation of a given linear pattern. M is also called a coefficient because it sits in front of the x. So what do m and b represent in the linear pattern like the tile patterns? Well, m is going to be our slope. Okay, so it is the slope of our line. It's going to tell us how steep. So steepness and direction. So steepness and direction of the line. And then the b, that's going to be the y-intercept, our starting point. We'll say starting point when y is 0. So what effect does the m have on the graph of the line? What about the b? So the m, which we actually just said, is going to tell us about the steepness and the direction. I'm just going to draw an arrow because I just wrote that down. And then the b, that's going to be our starting point, our y value, where it's going to cross the y-axis. Okay, number 34. So we are going to find the slope of a line without graphing. So we are given some points. We're given 6, 5, and 3, 7. And Gloria figured out that the change in y is -2, and the change in x is 3. So explain how you could find this without graphing. So what we can do is I'm going to label my x, y, x, y. So if I want to find the change in y, we are going to subtract. So we have 5 minus 7, which gives us our -2. And our change in x will have 6 minus 3, which gives us our change of 3. So we are subtracting those values. So I'm just going to say subtract. So now we can draw a sketch of the line to validate her method. So we have a point at 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And then the other point was 3, 7. And what we can do is we can connect these. Well, we can draw the line first. And then make a slope triangle and see that we're going down 2 and over 3. So we drew a sketch. What's the slope? Well, we just said it's -2/3. M equals. So using Gloria's method without graphing, we want to find the slope of the line that goes through the points 4, 15 and 2, 11. So I'm going to, again, label my x and my y's. So I'm going to find the change in y. So that's 15 minus 11, which is 4. My change in x, 4 minus 2, which is 2. And then that can reduce to a slope of 2. Using Gloria's method again, we're going to find the slope that goes through 2886 and 3483. So I'm going to label my x's and my y's. My change in y, do 86 minus 83, which is 3. Change in x, 28 minus 34, which will give us -6, which we can reduce to -1/2 as our slope. So we're finding the change in y over the change in x. So another student found the slope from part D to be +2. What error did they make? Well, they need to do change in y over change in x, and it looks like they did change in x over change in y.